Right. I think our next speaker here is here, and I'm happy to welcome Dr. Alex Groombridge, who is the co-founder and CTO of uh, Echion Technologies, and he will be speaking on the development status and roadmap for niobium anodes. And with no further ado, Alex, the show is yours.
Thank you so much. So yes, I'm Alex Groombridge from Echion Technologies. Sorry, that's a difficult to pronounce one there. And today I'll be talking around our unique anode active material technology, looking at safer, faster charging and longer lasting lithium-ion batteries, particularly with a focus on heavy duty applications. So I want to start off with a more general question, which is what really makes a good lithium-ion cell and a good battery, to be quite honest. When people think about this, they normally focus on one particular metric of choice, and they're quite complex systems. So they have to be considered holistically, looking at not just energy density, but also in cost efficiency, whether that's per energy density, per power, for how long it lasts, low temperature performance, safety, how long it takes to full charge, and others. And each particular application will have its own mix of what's desirable. So your passenger car EVs focus on cost efficiency, energy density, for example, safety, whereas a power-based system, which is what I'll talk about, is a slightly different focus. If we zoom in on these applications that are really looking for what we offer, this is the safe, fast charging and long life lithium ion cells. These are applications where we're looking at really industrial commercial assets that need to last for a particularly long time. And therefore, if you can operate your system, your vehicle for a longer period, make it last for more years, you ultimately save cost. So it's these high intensity, high utilization applications. So for example, buses, commercial fleets, delivery vans, trains, automated guided vehicles like trucks in ports. Mining is quite a big one, all the way through to high performance applications like motorsports or space, where you need a really fast charge, fast discharge, and long life, particularly for things like space. All these come together to be ultimately a niche market in the global battery field, but it's still very sizable, and it's currently quite unserviced. You can't get batteries that tick all of the boxes that you're looking for these particular applications. And why is that? So zooming in on particularly anode active materials in a standard lithium-ion battery, you've got three general materials here that are quite popular. Graphite obviously is the biggest one, silicon and lithium titanate. Where graphite materials, if you try and fast charge them, they have significant problems with safety. This is due to lithium ions forming lithium dendrites due to overpotentials. So they're limited in how fast they can charge. They're also limited in their cyclability. You won't be able to find a graphite battery that lasts for tens of thousands of cycles with a full state of window operation. Silicon-based systems, while very attractive for high energy density, and in theory they can charge quickly, they really suffer from a poor cycle life. So if you're looking at an application which you want to have high utilization for, it won't last particularly long. Lithium titanate does function particularly well. It's a high power based system. You can fast charge, fast discharge, and it can last for a long period of time, but they lack in energy density, which means they're not practical for a lot of these applications. So where does Echion come in? Where does our technology come in with our new anode active materials XNO? This is our new material based purely on niobium and modifications of this to basically swap out your graphites, your silicon, your lithium titanate in a standard lithium-ion battery setup in order to improve that fast chargeability, long life, and maintain that energy density. And I'll explain a bit more on that. It does this by being an inherently stable material, won't